Hello, welcome to the CISCO UCS Advantage video series, UCS Unified Fabric and I/O Flexibility and Performance. My name is Chris Dunk and I'm a Technical Marketing Engineer for the UCS Business Unit. I'm going to demonstrate how CISCO UCS offers the most flexible and performance-optimized compute network for low latency and high bandwidth. This visual outlines how blades are interconnected to a unified fabric. And if a blade in chassis 1 needs to communicate to another blade in chassis 2, traffic is passed through the blade NIC port into the chassis I/O module and switched at the top of the system. Chassis are not populated with any switches, so that blade-to-blade communications only have one hop between them. Even if blade 1 in chassis 1 wants to talk to a blade in chassis 20, it's still one hop. Every single server in the fabric has only one hop to talk to any other blade with the same predictable latency for all 160 servers. This far exceeds the legacy chassis blade communication model populated with switches where only a small number of blades can communicate with only one hop. Now let's explore the UCS advantage of flexible I/O choices for blade connectivity to the unified fabric. CISCO UCS is architected so that customers are not forced to over-provision expensive switches inside each chassis in order to provide adaptable bandwidth to the blades. CISCO UCS provides the ability to right-size the fabric to provide the bandwidth where it's needed in the system. With UCS, each half-width blade, for instance, is populated with an MLOM adapter that can provide 4 10 gigabit links and an optional expander or physical adapter that adds 4 more 10 gigabit links for a total of 80 gigabits of connectivity to that blade. And this can be done for every blade in the chassis. This flexibility comes with no need to learn or plan out complex in-chassis I/O mapping rules. So it's simple to scale bandwidth for a UCS blade by just increasing the chassis links and adding an expander or a MES in the blade, again with no switches required. Now let's look at UCS Manager and see the logical management of the network settings. For time's sake, we're going to look at a very simple method of controlling the network connectivity for an individual blade. By selecting a server's profile, which is the logical configuration of the server, going to the Network Configuration tab, I have the ability to simply edit the network configuration, including which fabric that NIC port may be located. Here we'll select the VM-NIC public connection, and we have the ability to modify the fabric ID that network is connected on. We have the ability to enable or disable fabric failover. This is the ability for a virtual interface card to have hardware NIC teaming for fail-on-fault network redundancy. This happens at the hardware layer and does not require the operating system to have any knowledge of the configuration. I also have the ability to change networks and configure these on the fly for this system. I also have the ability to increase the number of NICs or the network connections for a blade by simply selecting the Add button to create a new network interface for this NIC. By selecting the network as well as which fabric I want that network port to operate on, I have complete control at a logical level of the entire configuration for this blade's network connectivity without having to worry about complex mapping connectivity rules. This blade will have the ability to traverse either the A fabric or the B fabric with its NIC port through the UCS chassis to the fabric interconnect. We have seen the advantages of having a simple method of providing high bandwidth and low predictable latency for blade I/O and applications in CISCO UCS. With a single flat layer 2 compute network for 160 servers, right-sized networking providing bandwidth where it's needed, when it's needed, simple and flexible logical management of blade I/O connectivity with UCS Manager. Thank you for watching this UCS Advantage video series for UCS Unified Fabric, I/O performance, and flexibility.